Hi, and welcome to the Power Hungry Podcast. I'm Robert Bryce. I'm the host of this podcast, where we talk about energy, power, innovation, and politics. My guest today is Caroline Cochran, the Chief Operating Officer of Oklo Inc. Thanks, Caroline. Thanks for being with us today.
Thank you, Robert. Glad to be here.
So we're going to talk about Oklo and Caroline's company, where you've been working for 7 years, you just told me?
Yeah. Actually, we just passed our 7-year anniversary, I guess. Founded in 2013.
Gotcha. Okay. So my custom on this show is I could introduce you and talk about you, and I could talk about the fact that we're both from Tulsa, but I'm going to skip over that and let you introduce yourself. So please, if you don't mind, imagine you just arrived at a dinner party. You don't know anyone there, and it's your turn to introduce yourself. So please, Caroline, who are you?
Yeah.
Why are you here?
All right. Yeah. Well, I am from Tulsa. Sometimes I do start with that actually, because growing up in Oklahoma, I think, oil and gas is everywhere. And it's kind of king, especially in Tulsa, maybe, well, anywhere in Oklahoma, really. And so I think that was a frame of reference I came from before learning about nuclear power and advanced fission and everything else. So when I was exposed to it, nuclear power in college, I probably had a similar reaction to a lot of people, which is like a little skeptical, a little bit like, why? Didn't realize how much power it already provides in the United States. Just all the context, just like most Americans had basically none of that. So I remember that, and I think that helps me to always remember kind of like what frame of reference most people are coming at when they hear about it. But yeah, I was interested. I liked math and science. I got into engineering. I was a mechanical engineer in undergrad, and most of my classmates went off to oil and gas. But I did a few internships where I really learned about nuclear, and at the same time, I was getting more and more interested in environmental topics, and health topics as well, actually. And so it's kind of like, well, you can either go into nuclear medicine with a nuclear engineering graduate degree, or you could do power. There's also kind of interesting, non-proliferation or like defense applications. So there's kind of all of them seem interesting and potentially having a higher purpose, I guess, that really attracted me. So I worked for a year between undergrad and grad school in tech commercialization, but then got to grad school to do nuclear engineering. But not long after I got there, I met Jake DeWitt, who's my co-founder, but he was getting a group of students together to try to start a company. I'm like, well, I've been doing startup things since the early 2000s. Like I would totally be interested in kind of merging those two things that I enjoy doing or learning about. And yeah, so we were starting, and honestly, there's a group of a couple dozen students that each had their own ideas. So it took a little while before we really honed in on what a market would really want and what we should really do. And then launched as Oklo in 2013.
But you didn't start with the name Oklo.
Yeah.
What was?
Did I say launched as Oklo?
No. I'm just
Oklo launched in 2013. Yeah.
So
we were
what
right.
was the original name? U-Power.
Yeah. U-Power Technologies. It was honestly pretty bad, and I take full blame for that. We were sitting around. We were in late 2012 before we'd really launched as a company, trying to. We were putting out some proposals for SBIR grants, and just kind of that name was the best one of the ones that the three of us had come up with that night. So we stuck it on a piece of paper, and that was our company name until for a few years. But we had used the name Oklo internally as kind of what we're calling the Aurora now. And we realized we liked that name so much that we really just wanted to change the company name. So we did the whole change.
So let me come back to Oklo and why it matters, but tell me why your company. So if someone is listening to the podcast, doesn't know anything about you, doesn't know anything about nuclear energy, why do they care about Oklo? What is it about your company that makes a difference? And particularly when it comes to producing carbon-free electricity?
Yeah, I think there's an interesting fine line to draw here. Of course, nuclear power is, I think, critically important to the future of the world broadly, including all types of plants, honestly. And a lot of people don't know, so probably not including the listeners of your podcast, but maybe someone stumbled on that they don't realize it's more than half of our nation's emission-free electricity. So it's certainly not something that we want to get rid of at any point if we want to gain ground. And when we've seen countries that have deeply decarbonized, as I think you've talked about a lot, it's countries that have utilized a lot of nuclear power. So I think
the key for the key for Oklo is really, I'm just trying to jump ahead here, is that you've designed and are trying to get licensed a very small reactor, 1.5 megawatts.
Absolutely. Yeah. So that was kind of right after that, the next thing. So good segue. Okay. So, that's important. But at the same time, I think, what industry can you think of where it really hasn't changed in decades? Where they still kind of ask you, are you sure you want to do electronic documents instead of paper? And I'm not kidding you that that's a thing. And when I was in grad school, I would, one of my intros to a software that I was using was a picture of a punch card. And they're like, well, this is why there's this many characters in this code, because it started with a punch card. And so there's so many things that are kind of just from the ground up in what we call like existing power reactors that you see on the grid, light water reactors, that haven't changed, or that can be improved, right? And so we saw that, but also you can use totally different fuels, you can use totally different coolants. So much of this, it's new and it's old, right? It was looked at decades ago and for a long time, but hasn't really been commercially implemented. So we wanted to do something totally different scale, totally different fuel and coolant and everything else, and safety characteristics, and pair it with like a market that we saw really needs this kind of power. And so that's like distributed and microgrids that have really been exploding. I think the reason for the nexus of that occurring is not just microgrids in developing countries kind of starting to come, to be developing, but it's also the care for climate and emissions, because otherwise, why not just build a bunch of diesel generators? So I think what we're seeing, if I care about climate and they care about power on the small scale.
Well, so let me interrupt you there, because I want to make clear that 1.5 megawatts, the output, the electrical output of what you're designing, 1.5 megawatts, you mentioned diesel generators. That's a very common size in not necessarily portable, but skid mounted generators that are made by Cummins and Caterpillar. And you see them all over the developing world. You see them as standby generators in data centers. But that's key to what Oklo is trying to do, right? Is that scale, the size of what you're trying to develop, is one of the keys that sets you apart. Is that a fair assessment?
I think it is definitely one of the keys. I think one of the things we've said before is this could be kind of like our Tesla Roadster. So it's like a unique niche product for a market in need that may like be willing to pay for that niche product, because it would still save them significant amounts of money from what they're currently paying now. But to really make a change, what we see is fission has the power to hit a lot of different markets. So we're already working on kind of larger plants, but still kind of in the microreactor range, but closer to 10 or 20 instead of 1. And then those add up a lot faster. You start multiplying
10 or 20 megawatts. So you could do a whole village or a small town instead of just a neighborhood.
Yeah, exactly.
Okay.
So I think that is key, but really, and I'm going to try to make this as succinct as possible, but by doing everything from the ground up completely differently, from our quality assurance, from how we're digitally controlling our design and everything else, using a different fuel, different coolant, different size, everything, we're able to kind of force everyone to look at things in a different way. And where we really want to start with that is the regulatory system, because the regulatory system is built around these existing large light water reactor plants. And I think
which are 1,000 megawatts generally. I mean that's the most common one being built. The AP 1000 is what's being built at Plant Vogtle in Georgia. These are the plants that are being deployed at scale by Rosatom and other big nuclear companies in China and elsewhere, right? That they're 1,000 megawatts, and you're looking at a megawatt and a half. So that's really a fundamental break from what we've seen in other companies, other technologies, and so on. But before I get to that, let me. So just to put Oklo in context, tell me how many employees you have, if you don't mind.
Yeah, about 20.
So 20 employees, and if I'm reading my history right, and I'm referring to Rod Adams here at Atomic Insight, who's written about your company, it was in March you made an application. It was the combined license application for an advanced reactor. And you were the first company to do that since 2009, is that right?
We're the first advanced fission company to do it ever. But you're right. More than a decade has passed since any company has submitted a combined license application. And one fun fact, or sad fact perhaps, is that no license application that started under the NRC, since the NRC split off from the AEC, and basically the AEC broke up,
Atomic Energy Commission.
Yes, thank you. The acronym.
We have to let these
Since the Atomic Energy
listeners know
Commission,
about your acronyms as we go along here.
I'm sorry, it's a terrible habit.
No worries.
Basically, it split up into the DOE and the NRC, which is the Department of Energy and the U.S. Nuclear Regulatory Commission in the 70s. None of them have come online yet. So I think that's a really startling thing to tell people, and it's true. Hopefully Vogtle will be here soon, and we'll accomplish that.
So if I can interrupt, because I want to make sure I understand what you just said. So that of the combined license applications that have been submitted to the NRC over the last, how many decades would that be?
Yes. So
and none of them have come. None of those reactors have come online.
Basically, Let me be really specific. The combined license itself is kind of a newer process that was begun in the 2000s, but to get a license from the NRC, starting with it, whatever method, hasn't happened yet. Hasn't happened yet where it started producing power.
I see.
Where it started that application process under the NRC. So,
but Vogtle has gone through this process, but they're not built yet, right? Those plants are still being built.
I think it's built, but their fuel load hasn't occurred yet, I think, is where it's at.
Okay.
I'm not fully up on that. So what I'm trying to illustrate is it's an incredible challenge. And what our thesis is that if you can basically address the concerns of regulations inherently by your safety being so inherent and your security and so forth and all these other things, then it really should result in a more streamlined or more efficient licensing process, because fundamentally it's just totally different, and the public health and safety is being ensured not through a regulation that says you have to have this exact pump, which we don't even have, or something like that. I'm kind of giving not the best example, but the regulation could be very specific to the light water reactor type, and what we wanted to do is show you can go through the regulatory system as it exists, and I think the NRC is motivated to do that too, and do it faster, hopefully, and really change the cost paradigm for nuclear that way.
So in addition to only 20 employees, you want to design them, you want to build them and operate them. So this is a different business model as well than what GE would do, or Westinghouse, or I guess Rosatom would design, build, and operate. But I mean, that's a different business model. So why do you want to control the whole, I guess, the supply chain? Why do you want that end-to-end control over the system?
That's a really excellent question. I don't think I've ever been asked that. What we saw is, I think there can be a breakdown between, if there's a developer and their only goal is to get a design certification or other kind of design stamp, let's say, from the NRC, that they then sell to utility, that they build it, the utility builds it and operates it. The developer has kind of this unusual incentive just to get it out the door. Of course, they care about it being safe and stuff like that. But if they're not the people actually operating it and running it, I think there can be breakdowns between really thinking through the whole process all the way to what does it look like day to day to operate it, which is something that obviously we had to do when we filed a combined license, is put together operations programs and security programs and handling programs and all these kinds of things that we've been thinking about since day one. And I think there's both an efficiency there, but also just a real benefit to your ultimate end product when you own it like that.
So that you have more control throughout, and that feedback loop is all self-contained, then that you control everything soup to nuts. Let me hit on that one point that you made there about the security part of this, because it's one I wrote a book, I made a film. We went to Indian Point, the nuclear plant in New York. And one of the issues there was heavy security. Is that going to be an issue that's different with your reactor as opposed to the larger reactors? How is the security protocol? Because I ask this because you've got to convince the public, right? You have to convince not just the regulators, you have to convince a the general public that it's going to be safe and secure. So is the
Yeah.
security protocol for what you're designing different than the existing fleet of reactors?
It is. It is. Kind of has to be. But one of the things that is interesting, that you kind of have to just shift your whole mindset when you look at a plant like this. When you think about both, and I'm going to tie in. You asked about security, but operations is really a similar thing. You see potential for errors that really come mostly from human error, and if you can make it so that humans aren't required to ensure safety, which then kind of also dictates like a bad actor can't necessarily cause an event that causes poor safety or potential radiological issue, then you can really simplify both your operations and your security. And in fact, it's better to do that because you don't introduce a way for humans to either mess up the safety or to have a rogue actor. So one of the biggest threats when we did our security threat analysis was actually the threat of having an armed guard on site who goes rogue, because then he's trained and he or she is trained and has weapons and so forth. So it is kind of interesting when you look at it that way. Humans could actually be the worst threat, and so it's actually safer for everyone. And I think, in kind of a sad way, our culture has seen how things can escalate with armed response, maybe unnecessarily quickly as well. So when it comes to public relations, I don't think you necessarily need to be armed. And when it comes to security of the plant, that's what we've proposed. Is it's actually the biggest threat that we found when we did our analysis.
Huh, okay. So one report I saw said that you'd need about $10 million, or your cost to build the first of a kind. And you have a site at the Idaho National Lab outside of Idaho Falls. You're going to be able to use fuel, which we'll come back to in just a minute, from the Department of Energy. But it's about $10 million for a 1.5 megawatts. I mean, I know it's first of a kind, but that's roughly $10 a watt. Do you expect that cost to come down? What is your target price for then a 1.5 megawatt reactor that's ready to go, a turnkey operation?
Yeah, it's we actually don't often talk about capital costs, just because like most products, they don't actually talk about how much it costs them to make it. They talk about how much it'll cost you, and when it kind of depends on the implementation how much it would end up costing, right? Like, how remote is it, how do we do the construction, how do we do the shipping, and all those kinds of things. The biggest costs are actually the kind of I'm missing the word, but the variable cost, basically, of the fuel. The structure and all the kind of components themselves outside of the fuel are we've tried to make as inexpensive as possible. So using kind of standard tubing sizes and using standard steel. So we're not using exotic materials and we don't have to apply certain types of quality assurance or procure them only from people who basically charge a 10x or sometimes even 100x multiple on something that you can get commercially elsewhere with high quality assurance. So we've really focused on bringing that cost down. That being said, yes, this first application we filed for is kind of a first of a kind, and for remote areas that are already paying high costs. So for them, it's a cost savings. And it depends on the area, like exactly how much, but
Sure.
we've looked at it being, and it really depends, but it can save them up to 50%, let's say, on their electricity bills. But right away, as I was mentioning, is we're working on the next one, which will have really huge cost savings compared to that.
So what do you expect that watt hour or kilowatt hour cost then to be? What do you expect then if, in Lebanon and remote areas, it's common where you're using oil or diesel fired gen sets that electricity costs would be 30, 40, 50 cents a kilowatt hour. What do you expect then for your cost to be? Because that's some of the competition you're looking at, right? To displace diesel or oil fired generators, right? So what do you expect that kilowatt hour cost to be?
Well, so I'm going to answer that probably longer than what you want. But again, the fuel is the biggest variable cost. And so it really depends on how we can get fuel. And right now, that's not commercially available in the United States. It is commercially available internationally. We're trying to figure out how much that's going to cost. But like you mentioned earlier, we're pretty vertically integrated, and now we're starting to be interested in being even further vertically integrated and just make our own fuel as well. The real power of this, and one thing we're excited about our first of a kind unit, of course, it's a unique kind of one, almost yeah, it's basically one-off because of the fuel from DOE. But that fuel from DOE is already recycled material. So we're already demonstrating utilizing recycled fuel material in our first of a kind plant, which was kind of previously a goal that we thought we'd have, maybe a few plants down the road to show, fuel recycling, but we're going to be doing it with our first of a kind. But that's ultimately where you get your big cost savings. So what I would say is if we can, once we get to between 5 and 10, I'd say we're planning to really start implementing some of those things as far as having our own fuel manufacturing plant. And actually what we're interested in is even recycling fuel from light water reactors. So what we're looking at Idaho is from a research reactor that was already kind of high enriched, but we can actually recycle low enriched fuel as well. And it's starting to look incredibly compelling to do that. So we think costs can get extremely low. I would hesitate to put out a number, but I'm going to put out a number anyway. I'd say on the order of a couple cents a kilowatt hour. Yeah, so that would be more nth of a kind.
Sure.
For these early ones, I think it's kind of fruitless to really talk about that until we really know our fuel supply.
So, but that's always the key, isn't it? I mean, when I talk about energy and power systems, it's the issue of scale. Can you scale it?
Absolutely. And
so
we already have an order book.
You said you already have an order book?
Yeah, basically.
And can you tell me how many orders you have?
Yeah, I mean, I think it's kind of contingent on how well the first of a kind goes, right? But yeah, I think we already kind of really have our sights in mind of what the first 5 to 10 look like. So I think we're not worried about how do we scale. It's just how quickly does it happen. And once we sell our first one, we're in the black, so we can keep operating. And so
but the
you're right.
Key there is that scalability, yeah. Right? So that you can manufacture these in the same ways that Cummins builds I don't know what it's 100-liter displacement diesel engine or Caterpillar or something, the ones that would be the gen sets that you would be displacing potentially, right? So you want to have a manufacturing. Then this is always been the discussion on SMR, small modular reactors. That's the niche you're in. So if you blue sky it for me, how many of these could you manufacture in a year? Boy, there's a long pause.
Yeah, the sky's kind of the limit. I mean, I think we're budgeting for on the order of, and again, it wouldn't just be the Aurora, it'd be this kind of next design that we're already working on. So I think, and then you're multiplying by tens of megawatts, obviously, and you're getting to those really low cost numbers. I think in the next, like from our very first build to a couple of years after that, maybe on the order of like a couple per year is kind of, I think, what we're looking at. And then really launching from there. So after that, like maybe 10 to tens of plants a year. So yeah, we're not single-handedly
in a decade,
changing climate change that way, but yeah.
Sure. So in a decade or so, you could be producing dozens of these potentially a year. Yeah, if everything goes well with licensing and safety and everything works out the way you think it does, then that's the goal, right? Is to be producing these by the dozens and deploying them all over the world. One thing that I would, you brought up regulation. Yeah, that's exactly the goal. A lot of people don't know the NRC's kind of had some interesting foresight. They actually already have a pathway called a manufacturing license, so you can do it that way. And as well, they have this process where you can basically utilize a sample cola and carbon kind of copy it and use it as a subsequent cola. So they call combined license application. Okay. Yes. So
so we can copy and basically utilize our first combined license application over and over again with changes per each site for the reactor. So that's the goal, is really having a new new efficient process for these smaller reactors. And again, they're on their order like a research reactor size, right? So it should be different. And then you can utilize that to have subsequent colas come much more quickly.
I see. So here's a question I like to ask of people in business, and I'll just throw it out there. So what's been the hardest part of this? What's been the hardest part of making this? Well, I ask it this way: what's the hardest part of your job?
That's a great question. I think the hardest part of being in a company like this can be that it's such a long road, right? Like I've already, I think people think we're young, but I've already been doing this for 7 years, and we just got an application in. So it does take it's a long road, and you have to really care about it. Like you genuinely actually have to care about it in order to care enough to kind of live the startup life for a decade of your life. So I think that's one thing that's challenging. I think one thing that I wouldn't have anticipated as being so hard as it is actually just the existing industry and basically the challenges of being categorized as a part of an industry that you really have no relation to as far as like most things that you're doing. And even within advanced reactors, there's not a ton of collaboration, just because there's, everyone's using different fuel types, looking at different sizes, looking at different issues. Some are using different regulatory paths. So I think just that kind of like that difficulty, because you're trying to change something that's so hard. And sometimes I've wondered, like, what was it like for Tesla kind of really trying to prove to people that an electric car could be the next wave, instead of like back when, the big three weren't really producing that and stuff like that. What was that like to be part of that industry, but not really similar to it? And so sometimes I wonder if that's part of it.
So would it be then, the hardest part is keeping the faith?
Yeah, maybe that you're just getting the raw me for this week in particular. It's challenging when you're kind of, feels like we're getting to what I'd call act 2. It's like, oh, it's great, we're a new startup, we got these fundraisers and stuff like that, we got our application in, woohoo. And then now it's like we're getting the petitions to intervene, and now people are like, even within the industry are like, well, they say they can do this, but they really can't, or something. And so, it starts to take a toll. And so I think this week in particular, it's tough, but there are so many people who are excited. And so, yeah, I think it's easy to keep the faith when you're really passionate about it, like we are. And we've got this small dedicated team that's just really passionate about bringing this new technology to light, and really about the environmental aspects of it. So it keeps you going when it's not really the money yet.
Maybe. So who are your competitors? Who do you view as the competition for what this niche that you're trying to fill? Who do you look at the landscape and say, oh yeah, we're competing against them?
Our competition, I don't think I've been asked that question, but when you said that, my first thing is like, our competition's ourselves. Like, we really just have to do what we have set out. And the reason why I say that is because there really isn't a solution at 1 megawatt that can provide clean power 24/7 for 20 years without refueling. It's just not possible. Like, the logistics that enables, and the ability that enables, there's nothing else that can provide that quite with that kind of uptime, and with that, with clean power. So and so there's no real competition for that. But
well, so that's your sales point, right? That we can build you something and you don't have to touch it for 20 years, and we're going to produce megawatt hours upon megawatt hours, and you don't have to touch it. I'm just trying to think, what does that sales brochure look like? So if you were going to tell me those 3 things, what are they? Why, if I'm operating a mayor of a small village in Alaska, or I'm operating a mine somewhere a long way from everybody else, what are the 3 things that are going to make me buy an Oklo 1.5 megawatt reactor as opposed to a diesel genset?
I mean, it's interesting you chose 3 things, because we always say reliable, clean, and affordable. And I think it really is the triad of those 3 things that make it most compelling. But if you take away any one of those 3 things, there are competition, right? So like, if it's not clean, then diesel genset. If it's not reliable, then I think there's a lot of renewables that can produce clean power for certain portions of the day, and with certain types of backup, they could have it mostly covered and things like that. So and then the affordability is what ultimately brings people to the table, right? Like, people can say things about how much they want clean all day long, but when it comes down to like, well, do you want to pay X price multiple? And then they're like, yeah, probably not though. And I don't think we should be and to your point, one of the messages I think you brought so clearly is, why would we ask the developing world to do something we ourselves in the developed world aren't willing to do, as far as pay multiples to get reliable power to our grid?
Well, so then let's talk about that, because I've made a few points about where these your reactors might be deployed. Who do you see as your first markets? Where do you think this will gain traction? Gain the most traction?
Yeah, we have, I think once that first of a kind rolls out, it will change things because people will be able to see it in practice. Like no one really wants to be the first. And I think there's kind of a little bit of an issue with even being the second. But once there's a couple, I think, and if, assuming it's successful and the community is a good, advocate like that we're in, working with, if we have good relationships and other people see that and they want that as part of their, clean microgrid, I think that really sets the ball rolling quickly. But for those first couple, our first one absolutely is at INL. And then, we're looking at, working with other sites in Alaska is kind of a pretty classic example. It's an area where, people forget, but in the wintertime, it's dark most of the time, and so solar is not quite as much of an option. Of course, in the summer they got a lot of light, but as far as year round, they really have that need. And there's also energy poverty, but also people think of Alaska as pristine, and largely it is. It's beautiful, but they also have some of the most polluted cities in the United States. So I think they have those twin major motivations to look at this. So we've been there and a part of talking to people there, and so I think I see that as the next one. But I've had a lot of outreach from places all over the world, whether it's resorts or islands or communities or you name it. It's been interesting. So it kind of, from the first couple, it goes from there. But that's a snapshot of what our customers do.
So the isolated locations, island economies,
Yeah.
remote regions, are Arctic or Nordic areas. Those would be the ones where you would be competing against diesel generators, and that's where your economics are the best. Then is that fair?
Yeah. In most areas, and of course, diesel fuel can be multiplied in its cost by how much diesel you even have to burn to get it to that location. But
sure.
I think the more remote, the more expensive the diesel becomes, and also the more of a logistical hazard it becomes for the people relying on it.
And what about military applications?
Yeah, I think the United States is looking at both privatizing its electricity supply, but also trying to make sure that if something were to happen, that they could still provide power to their core, kind of assets and core functionality.
And not necessarily rely on the local grid.
Yeah, the local grid, or even huge fuel tanks or something like that. So I think that's also a big one.
Well, so it's interesting. The blast in Beirut happened just a few days ago, and I've been in touch with people in Beirut who are talking about the fact that diesel fuel there is in short supply. So it's just one thing that it pops into my head is that you really have a potential for a new type of microgrid. To me, microgrids so far have been around diesel gensets and solar panels and batteries, right? That's when I hear a microgrid, that's what I think of. So your idea is now Oklo could have the potential for nuclear microgrids.
Yeah, I think we really haven't looked at how you could utilize fission in a distributed way. And so that's something that's exciting to us.
Gotcha. So you put something on Twitter. I'm trying to find that. You said on Twitter that regulatory risk we're tackling head on, and that you need better public understanding of advanced fission benefits. So you got funding from, I'm here in Austin. One of your funders was Trusted Ventures. That they look for companies that are trying to make headway in very regulated industries. So I've read about the regulatory process at the NRC, and some things have been published saying that it can cost $500 million to submit a license for a new application. I'm guessing you all didn't spend $500 million.
We didn't. No. We try to learn lessons learned from people who went before and hearing their stories, but also I think there's a number of reasons why the agency itself is doing some self-examination and thinking about there's a way to do this without completely killing the industry or not letting anything kind of get built. And I'm saying that because, again, nothing's come into operation since was started under the NRC, and I think that's coming home to them. And so I think we kind of had a bit of luck to be coming in at a time when I think they're realizing plants are closing left and right. And it's not about safety. It's about we have to be ready for these different types of technologies that we haven't been. And I think that's been not just the NRC, but the DOE has been supporting it. Congress has been encouraging it. So one I think big reason why we didn't spend what was spent before is because our application.
You didn't have the money.
Yeah, well, we didn't. No, we didn't. And we keep telling people that. Yeah,
with 20 employees, you'd have be an expensive application.
Yeah. Yes, that's very true too. I think people are like, well, we're not used to we've heard the narrative from people in or around the NRC that was kind of like, well, we're not used to companies caring about how much they're spending too much. And I'm like, well, that's probably what caused, there's some major issues. And also like it creates a PR issue for us as well, where, and again, we're part of this industry, but we feel like we're very different, where it's like, hey, well, no nuclear project has ever, been built on time or remotely close to budget in recent years. And so that's hard to argue against until we do something different. And so that's one thing. But yeah, the regulatory risk is significant, but I think our application enabled kind of a fresh start for everyone involved to say, this is a whole new industry. It's a whole new way of looking at fission. How do we regulate that? And we put some proposals on a paper. And so you're absolutely right. It can be tens to hundreds of millions of dollars. But that's not what we've spent so far, but we're trying to hope that this trajectory that we have right now continues. But for now, we've spent fractions of what was spent previously in pre-application, and our acceptance review is not fractions, but what we're budgeting for the total application review is. So I think we're on a good trajectory there, and I think it should be, because we're looking at a 500 times smaller plant. And it's not just about that, it's all the inherent simplicities that are part of that too, that really should be different. And so this is kind of forcing the issue.
So about how much will you spend just trying to get the license?
Yeah, I'd say about 10 million total.
So is that how much you've raised so far? Or, I mean, I know you've gone through several funding rounds. I mentioned Trusted Ventures. Are you disclosing how much money you've raised?
Yeah, we haven't done a formal announcement of our last fundraise. But I could say, it's on the order of between 20 and $30 million is what we've raised total so far.
So in 7 years, 20 or 30 million, but to get to manufacturing, you're going to have to raise 2, 3, 4 times that much money to get in deployment.
Yeah. We're likely to do another fundraise here soon, to really support scaling up and everything else that goes on as part of that. So yeah.
So blue sky it for me here. Now you're how old are you? Do you mind if I ask?
Yeah, I'm 37.
So by the time you're 50, blue sky it for me. What does Oklo look like in 13 years?
Yeah.
It's okay. Yeah. No pressure. There's no, paint the picture for me. What does it look like?
I'm just hoping I'm like on a vacation at some point. Like there's some kind of like tropical island in my future.
Beer that's this size and there's a palm tree. Okay, well that's okay.
That's where I am. No. I really care a lot about this. But there's also it's funny. There's also other things that I feel like I would like to start a company around, and some of these health issues that are out there and things like that. So I see myself like eventually like 10, more than 10 years down the road, probably not exactly here, but yeah, Oklo in 10 to 15, 20 years, I think we could be considered basically a unicorn as the term is used. I think we could really be part of, and we've said this before, is like the tip of the spear to a new wave of like fission for the world, right? I think it has to start in the United States, because the United States has the expertise. They have the data. They have from existing or from previous tests done on advanced reactors of a lot of different types. And the world does frequently look to the NRC as a standard for regulatory stuff. So that's why we started here, even though it's harder. We had random people, not our investors now and not Trust Ventures, but we had people who were like, well, why don't you just go to, X developing country and they don't have any regulations, so it'd be much easier. And, ultimately it's worth it doing it the hard way, we believe, because once you get through it, the whole world will feel like you've been through a very rigorous process, and we will have proved it out.
So once you get that NRC stamp of approval, then that's proof to the world that we've gone through the most rigorous examination possible. And if it's good enough for NRC, it's good enough for Ghana or Zimbabwe or South Africa or anywhere, any other country in the world. Is that a fair assessment?
Exactly. And no one in the world wants to feel like, oh, you couldn't do that in the United States, so you're coming here we're kind of the seconds or something. And that is absolutely not our trajectory. But I think what I'm answering in a roundabout way is I see in 15 years, Oklo is a truly global company with an array, a stable of different advanced fission generators or batteries or power plants or whatever, at all different sizes that we're providing all over the world. And I think it could be very exciting because hopefully, honestly, people ask, you asked a little earlier about our competition for this first one, but even for all these different types, the world spends $1 trillion in energy. And I know you talk about all the different types. It's a huge market out there. It could be an extremely huge market for Oklo, but it could also just be the beginning of so many different companies bringing forth all kinds of different plants all over the world. And I think that's the vision that I'd like to see, because we don't have any time to waste with further, however you look at pollution or climate, we don't want more of it.
Right.
And so providing that is where I see it going. And I think it could be just absolutely astronomical within 15 years, which sounds both kind of far and kind of close, honestly. But yeah.
Well, the market is enormous. I mean, the U.S. electricity business in the U.S. alone is $400 billion. I calculate it globally at $2 trillion, just the electricity sector, because the U.S. is about a fifth of global electricity. So at that rate, $2 trillion a year business. So there's a lot of opportunity for people who build better mousetrap, better reactor, especially if it's carbon free. So I don't want to make this interview go on too long, but we've talked about how big Oklo could get. What business leaders or businesses do you admire? I mean, you've been at this now for a long time. You've made it clear that you don't fit within the nuclear sector that exists today, because it's largely owned by very large utility companies with different types of reactors. Who do you look when you look around the business world, because you're trying to make it in business? Who do you admire?
Yeah, that's a great question. I do feel like we're kind of in our own way, but I think there's certain things that really influenced us. I think design and world impact. I think Apple has been one of them, which is probably most people are fascinated with that story and just how they package all their products and make it so compelling and easy to use and
Johnny
beautiful. Ive. And I also became really interested in books like Conscious Capitalism and things like that, like a while ago. So I think some of those principles are
John Mackey from here in Austin, Whole Foods Market.
Oh, okay. Yeah. Very, I don't know, influential to think about kind of how Starbucks started, or, was really thoughtful about how to provide employees with good benefits, or like similarly with Whole Foods. The Whole Foods story was really interesting to me, how they really, you would think a grocery store is kind of like a more basic job or something, but they found ways to grow teamwork and form teams within Whole Foods and get them to compete with each other in a fun way, and really own and care about their areas and empower their employees and make them feel passionate about exactly what area they were in. And so I think everything can be, when you enable your employees, you can really enable your everyone enables each other that way. Like it just lifts everyone up. So I think all those kind of characteristics that really influenced me in particular. I think there's a lot of other interesting stories out there, but those are the first couple that come to mind.
Any female entrepreneurs that come to mind?
I guess that's that I don't have any that come to mind, actually.
No worries. And in terms of just on that same line, a business, I mean, you mentioned the companies you admire, and maybe this is redundant here, but business models, or I guess, you're trying to blaze a whole new pathway here in a sector that has been, as you said, not very dynamic in terms of new technology for decades. So is there, Apple kind of did create a new business model with design first. Any other models like that come to mind? Or maybe I've exhausted this topic already and I'm beating it too much, but I just think that you're out there on the technological edge, and it's clear from the design of the powerhouse that you take the design part of it seriously. Any thoughts on that?
Yeah, I don't know if I'm answering exactly your question, but I think so. It just jogged for me, like how I usually think about this, which is we're doing something so hard, so hard, and all the pieces have to come together. And I frequently think about it as if it's like a 3D puzzle where all these pieces are like collapsing in on each other, and they all have to line up just exactly the right way at the exact right time in order for this to like work, right? So the public does have to learn about not just nuclear power, I think in general, but also what can be done differently about it. I think that is a piece. I think we frequently say, oh, well, there's public perception issues, so those will have to be addressed first, right? I do think you kind of have to build and show it can be different, right? Like, why would the public trust you until you've really shown that can be done? So that's a big part of it. So many things with supply chain have to be done totally differently, and design, I think, is a big part of that. So you kind of mentioned that, but making it appealing and artful is something that matters to most humans. It's just a human trait to care about how it fits in socially and artistically. And so I think we've had our eye on all of those things at the same time, but it is challenging to pull it all together with 20 people. And, so we're growing, but I think we've done a good job so far. Another thing that is interesting with such a long road of a company is you kind of have to pace yourself, right? If we try to like put out all these press releases like 7 years ago, we'd be old news by now. And it's like, we just kept our head down, and people kept saying, oh, you need to do press, and you need to like get out there and like put out press releases. And we're like, no, we just really need to do the engineering work. And so we really focused on that. And now that's coming to fruition finally. But for so many years, we did kind of have to deal with people being like, well, we don't know what you're doing, or they're not really doing anything. So I think finally it's kind of coming to fruition, and now we really have to focus on kind of that other public outreach part of it too.
So to that end, and I meant to ask you this earlier, so what do you want people to do? What is your call to action? What for people to get more information about Oklo?
Yeah, I think, well, thank you for having me on. It's just great to have a conversation for people to hear some of those stories. I think firsthand does make a difference versus, I mean, I could put it on our website or all kinds of different posts, but I think it's just great to have the chance to talk with you. And you have
sure, glad to do
such an interesting work that you're doing, and so powerful and important. But yeah, I think, if people are interested to follow up or be part of kind of our story or follow along as we kind of go through these steps, you can follow us on socials, of course, Twitter, LinkedIn, Facebook, and so forth. But our website is very simple still. It's oklo.com, but it does have the functionality where you can find the socials there. And you can also sign up on our mailing list, which we've sent out 1 or 2 emails so far total on that list. But we're looking to really invigorate it and draw people in more, because there's so many people who are like, I love what you're doing, I want to be a part of it. How can I help or join or whatever? And so we're thinking about creative ways to just pull this basically team of, extended family and friends, I guess I'd call it, of supporters that are excited about what's going on. So feel free to join that mailing list. We won't spam you, but we can kind of keep you up
I
to
can
date.
attest to that. I've signed up and I have not gotten a single thing from you. So
yeah.
Okay, so just a last couple things. So what are you reading? Are you reading books? Who do you like when you read? I know you're working hard, but I'm assuming you're not working all the time. What books have you been reading?
Great question. What do I read? It has been pretty sparse lately. I used to
I'm putting you on the spot on all kinds
fun.
of things here today, aren't I? You're oh, Bryce, what are you doing to me?
Yeah.
No, I don't know.
I don't know. Yeah, I may or may not have gotten a couple hours of sleep last night.
Okay, no
worries. I think some of the books I really enjoy are like, again, about like health or environment or animals. One thing that I've enjoyed passively or like secondhand is Jake's been reading about like different books like plant intelligence and things like that, which is absolutely fascinating. Would never have even guessed that was possible, that they have these kind of hormones and basically types of intelligence. I think that's really fascinating. One of the more recent books, although I think it was still a year ago, was I was reading about bats and different conservation efforts there. But yeah, I need to be reading more.
Yeah, well, I love bats. Austin has a big bat colony downtown. I've interviewed Merlin Tuttle, who's one of the world's renowned bat experts. So I'm down with bats. Okay, so last question: what makes you hopeful?
I'm hopeful because I do basically believe that people want the best. We may all disagree or get different news. I guess I'm hopeful that frequently, if you get the chance to really talk to someone, that you can have a dialogue. And I think some of that feels like it's breaking down in COVID, where all of our conversations are through a screen and that kind of thing. But like life goes on, and I think life finds a way. People find a way, and I think I've seen things like what you're putting out, and Pinker and so forth, like just facts about the world. It is improving. I think with more power, it can continue, like more clean power especially, but more power in general, all of the different human markers go up, and we've seen that. And so I think that's something really exciting. It's not just humans either. It's the environment can improve, I believe. It hasn't always with increasing prosperity, but I think animal welfare and environmental welfare can improve at the same time. And we've made it this far, so I keep getting, you got to celebrate the wins. So for my personal work, I'm excited about that as well.
That's great. Well, Caroline, it's been great fun talking with you. So all of you out in podcast land, if you like this podcast, go to ratethispodcast.com/powerhungry. And give us 5 stars. Subscribe to the podcast. I'm easy to find on the web. You can buy my books. You can buy the film. I got the new screen behind me there. See, look, that took a while, but the logo for Juice, How Electricity Explains the World, in which we talk about at significant length about nuclear energy. But Caroline Cochran, thank you very much, the Chief Operating Officer of Oklo. Go to their website, oklo.com, to register for their newsletter. And that's it for this episode. Thanks for listening, and I will see you next time on the Power Hungry Podcast.